Good morning, dear students. Once again, we are here to discuss RDO Worksheet-62 from your chapter Magnetic Effect of Electric Current. And today we will discuss about the magnetic field due to current through the circular loop. It can be represented by the concentric circles at every point. Okay, circle become the larger and larger as we move away. These circle become larger and larger as we move away. See, every point of the wire carrying current would give rise to the magnetic field. Every wire give rise to the magnetic field appearing as a straight line at the center of the loop. This is the straight line appearing at the center of the loop. Okay, so the direction of the magnetic field inside the loop is the same. Now, factor affecting the magnetic field through circular current carrying conductor. First, magnetic field is directly proportional to the current flowing through it. Magnetic field is directly proportional to the current flowing through it. Means if the value of current is increases, magnetic field increases. If the value of current is decreases, magnetic field decreases. Magnetic field is inversely proportional to the distance of the conductor. Means what? If the distance increases, magnetic field. If distance increases, magnetic field decreases. If distance decreases, magnetic field increases. It depends upon the number of turns also. More number of turns means more magnetic field. The magnetic field is additive in nature. The magnetic field of one loop is added up to the magnetic field of the another loop, right? Next we have solenoid. Solenoid is nothing but a kind of coil of many circular turns like this. You must have seen the spring. It is in the shape of that spring. A coil of many circular turns of the insulated copper wire wrapped closely to the cylindrical form. It is just like this, okay, and this is attached to your battery and key. It is acting as a solenoid, okay. Then we have magnetic field is uniform inside the solenoid and represented by the parallel field lines. It is uniform throughout the solenoid and uniform inside the solenoid. Direction of magnetic field outside the solenoid, it is from north to south, but inside the solenoid it is south to north. Solenoid can be used to magnetize a magnetic material like soft iron core. Solenoid is used to see this figure. Solenoid is used to magnetize this soft iron core. Now we have what is the difference between electromagnetic and permanent magnet. It is a temporary. Electromagnet is a temporary magnet, so it can be easily demagnetized. Whereas permanent magnet, it cannot be easily demagnetized because it's a permanent magnet. Strength can be varied. In case of electromagnetic magnet, strength can be varied, but whereas permanent, strength is fixed. Polarity can be reversed. Polarity of electromagnet can be reversed, whereas the polarity cannot be reversed. Generally, stronger magnets, electromagnets are generally stronger magnets, whereas permanent magnets are weak magnets. Okay. Now coming to the question answers part. What are the factors affecting the magnetic field? Then you have to write all these factors which are related to the magnetic field. Magnetic field is directly proportional to the current through the conductor, inversely proportional to the distance from the conductor. Magnetic field is directly proportional to the number of turns, etc. Second question we have, consider a circular loop of wire lined Consider a circular loop of wire lying in the plane of the table. Less the current passes through the loop clockwise. Apply the right hand rule and find the direction of the magnetic field inside and outside the loop. Students, inside the loop it is inward, okay, and outside the loop it is outward. It's as simple as it is. If you are talking about inside, it is if you are talking about inside, then we have it is in between. It is inside the direction of magnetic field inside the loop will also be going to the through the same. Means you can say it is if you are talking about this, it is if we consider it as a circular loop, then inside the circular loop it is downward, and outside the circular loop it is upward. Okay, so you can write easily. By this way you can easily, yeah, this is the way you can easily show the values. This is like in this direction we have upward direction, upward field lines, and inside it is downward. Okay, downward lines. Again, this is upward lines and inside it is downward. So you can easily give the answer of this question, that in this kind of diagram current is flowing clockwise. We are applying the right hand thumb rule to the left side of the loop, then the direction of magnetic field lines is inside the loop are going into the table, while outside the loop they are coming out, means outward. Okay, third question we have, what is electromagnet uh, and how it can be formed. An electromagnet is a magnet that runs on the electricity, right? And electromagnetic, the strength of electromagnet can be easily changed by changing the amount of electric current. The poles of the electromagnet are even by reversed or by reversing the flow of electricity. Okay, so you can easily write about the electromagnet. Means the current carrying solenoid coil is used as an magnetized steel is acting as an electromagnet. Okay, you can write all these points also in case of electromagnet. Next we have solenoid. You have to write all these points, you can, and draw this diagram also. What is solenoid and where the magnetic field uniform in the solenoid? It is uniform inside the solenoid and represented by the parallel field lines. Last question, differentiate between the electromagnet and permanent magnet. Then you have to answer this, write the answer of this, right? So this is all about your today's worksheet. I hope you understand it. So do like, share with your friends and subscribe the channel. Thank you, bache. Take care.